Okay, so in this video here, we're going to be talking about factoring quadratics. Now, in this video here, we're going to be talking about quadratics where the a coefficient is going to be equal to 1. Now, whenever the a coefficient is equal to 1, it's a lot easier to factor because you don't have to factor by grouping. So I'm going to make a whole nother video on factoring quadratics when a is not equal to 1 because that takes a little more work and there's more steps involved. But this video here is going to be dealing with quadratics that all have that a coefficient equal to 1. Now, what you're looking at right here is a quadratic in standard form. You can see ax squared plus bx plus c. That's how we want all of our quadratics written. And sometimes we may have to move a term over in order to get our quadratic in this format here. But when we're factoring, we're going to want to have it in this format here. Ax squared plus bx plus c. Again, that is a quadratic in standard form. Now, there's three things you want to remember when you're factoring a quadratic. So let's go ahead and take a look at those three things. Okay, and you can see right here, it says steps to follow. We have 3 steps to follow, and you want to go right in order here. Step 1, put the quadratic in standard form by setting equal to 0. So when you're given the equation, you want to make sure that you put the quadratic in standard form, and you're going to do that by setting it equal to 0. Okay. Now, sometimes it may be done for you. You may not have to do that, but if it's not, you want to make sure you set it equal to 0, okay? Step 2, see if you can pull out a greatest common factor between your terms. So after you set it equal to 0, see if you can pull out a greatest common factor, because if you can, it's going to make the problem much easier, okay? And then step 3, factor using the AC method, all right? So sometimes when you pull out a greatest common factor and you're doing step 2, you may not have to do the AC method. It may be completely factored after you pull out that greatest common factor. So always try to do that first, and then you move on to the AC method, which we're going to talk about right now, how to perform. All right, so let's take a look at our first example. So here's our first example, and let's go right through our steps. Is the quadratic in standard form? Now, it is equal to 0, so I'm good there. Step 1 is done. Now, step 2, can you pull out a greatest common factor? Well, look at your coefficients here. I technically have a 1 here, I have a -5 here, and a -6. Do they have anything in common that I can pull out? And the answer to that question is no. I mean, technically you could pull out a 1, but that's not going to help you any, okay? So we cannot pull out a greatest common factor, so now we go to step 3, which is using the AC method, which you don't know how to do yet, but I'm going to show you right now, okay? So let's get rid of this stuff here. To do the AC method, it's exactly as it sounds. You're going to multiply A times C. So for example, I'm going to write A times C. Now, what is A? What is C? If you forgot, I wrote this down in the corner of all of the problems, ax squared plus bx plus c. That's the quadratic in standard form. So I can see here that my A is that coefficient in front of x squared. So technically there's a 1 here. That's my A. My B is that -5. And my C is the -6, okay? So if I were to do A times C here, that's going to be 1 times a -6. Okay, so that's what I'm going to do here. I'm going to do 1 times -6. Let me get rid of this here. So we're going to do 1 times a -6, and we get -6, okay? So from here, you have to come up with 2 numbers that when you multiply will give you this -6, but add up to your B value, which in this case here is -5. So again, 2 numbers when you multiply will give you -6, but add up to your B value, which is -5. Okay, so that's the operation you're going to be performing when you're doing the AC method. So from here, you can make a list of numbers if you'd like. Okay, so for example, I'll just start with 6 and 1. Okay, 6 and 1. 6 times 1 does not give me -6. Okay, what if I make one of them negative? That works out perfectly. Okay, so that's what we're going to use here. So sometimes you may have to make a pretty long list here, but this one was pretty straightforward. Again, -6 times 1 gives me that -6, right? And then when I add them, I do get my B, which is -5. So from here, all you have to do is put it in factored form. You're going to be using these values right here that you came up with, and you're going to write in parentheses x, your variable, and now grab either one. You can grab the -6 or the +1. It doesn't matter. I'm just going to write -6. And then another set of parentheses, I'm going to grab the +1. So +1. There it is, completely factored out. This is done. So this is the factored form of that quadratic. Okay, so if they wanted you to solve the quadratic, you simply just take each one of your factors, you set them equal to 0, and you solve. So for example, I would have x minus 6 equal to 0 and x plus 1 equal to 0, and I would solve. If I solve this, I get x equal to 6 and x equal to a negative 1. Okay, those are the zeros, right? We call that the zeros. That's solving the quadratic. We're essentially solving where it crosses the x-axis. So this quadratic here is crossing the x-axis at 6 and negative 1. But again, they're not asking you to solve here. They just want you to factor. So we're going to stop there. We're just going to factor these problems. But if you were being asked to solve, you simply just take your factors, set them equal to 0, and solve. Okay, let's try some more examples. So here's our next example. Go through your steps. Is it set equal to 0? It is. Okay, can I pull out a greatest common factor? And the answer there is no, I cannot. Remember, I have a 1 here. All three of those terms there do not have something in common that I can pull out other than 1, and that's not going to help me, all right? So we're going to jump right into the AC method. So for this problem here, that's going to be 1 times a positive 16, which will give you 16, right? So I need two numbers when I multiply that will give me 16, but add up to a negative 8. So just start with 4 and 4. Okay, 4 and 4. When I multiply 4 times 4, I get 16. Okay, that checks out. When I add them, I get positive 8 though, not negative 8. So we need to play around with it a little bit. What if I make it a negative 4 and a negative 4? A negative 4 times a negative 4 gives me positive 16. And when I add them, that gives me the negative 8. So that checks out. I can go ahead and put it right in factored form. So I'm going to have x minus 4, okay, and then another x minus 4, and we're done, okay? Now, technically, if you wanted to get fancy, you could write it as x minus 4 and then square it. That would be totally fine too. So either way is totally fine. Now, remember, I just want to reiterate here, if you were to FOIL out what you have right here, right, first, outside, inside, last, so if you were to do FOIL, you are going to return this quadratic that you see here in standard form. So technically, you could check your work. You could do FOIL on this x minus 4 times x minus 4, and it should equal out to x squared minus 8x plus 16. So there's one way you could check your work if you wanted to. All right, but these are the correct answers, and that's how you can write it. All right, let's go ahead and try some more examples. So here's our next example, and you can see here that it's not set equal to 0. So I'm going to go ahead and take this term right here and move it over to the left-hand side. If I do that, I get x squared minus x equal to 0. Okay, that's step 1. Step 2, can you pull out a greatest common factor? So between these two terms right here, can you pull out a greatest common factor? And yes, you can. They do have something in common, and that's going to be x. So I can go ahead and pull out an x. That's what I'm going to do. So pulling out an x, and then I'm left with x minus 1. Again, this is all equal to 0. Okay? And so again, if I were to redistribute this x inside, I should get x squared minus x, and I do. Okay? Now, is there anything else you can do here? And the answer is no. There's nothing else you can do here. I no longer have a quadratic. I have the whole thing factored. This problem is now done. Right, so you can leave it equal to 0, that's fine, or you could write it as x and then x minus 1. You can leave it like that too. Either way is fine. All right, so that's completely factored. We're done. All right, let's try some more examples. Okay, here's our next example. And again, step 1, is it set equal to 0? And it's not. So I have to take this positive 4 and I have to move it over. So doing that, I'm going to get x squared plus 3x and then minus 4. All equal to 0, okay? Now, can you pull out a greatest common factor? And I cannot, right? All three of these terms here do not have something in common other than 1. So I can't pull out a greatest common factor. We're gonna go right into the AC method. So a times c here, that's gonna be 1. Remember, I have a 1 here. So 1 times a negative 4, that gives me negative 4. So I'm gonna put negative 4 here. So two numbers when I multiply will give me negative 4, but add up to 3. So again, just start with a list. I'll do 4 and 1, okay? 4 times 1 does not give me negative 4. Okay, what if I do negative 4? Negative 4 times 1, oh, that gives me the negative 4. But when I add them, I get a negative 3, not a positive 3. So, okay, let's go ahead and change the sign one more time. Let's make this a -1 instead of a -4. And if I multiply them, I get -4. That still checks out. And then 4 minus 1, I get the +3. There we go. I got the values. Okay. So putting it right in factored form, I get x plus 4 and then x minus 1. Also, I should probably mention that it does not matter the order here. Okay, I could have written x minus 1 first and then x plus 4. It doesn't matter because you're multiplying, right? I'm multiplying this factor by this factor, and you can multiply in any order. So it doesn't matter which value you grab first. You can grab the 4 first or the -1. It does not matter, okay? So the order here does not matter. All right, so that problem is now done, okay? And again, you can set it equal to 0 if you would like, or you can just leave it like this here, okay? It doesn't really matter. All right, so that's done. Let's go ahead and try 2 more problems. Okay, so here's our next example, and I want to make sure it's set equal to 0, and it's not, so I have to take this 4 and move it over. That means I have to minus 4. If I do that, I get x squared minus 4x, and I'm doing -28 minus 4. That's going to give me -32. And again, all equal to 0. Okay? So from here, can you pull out a greatest common factor? You cannot. So we're going to go right into the AC method. So a times c, that's going to be 1 times a -32. That's -32. So 2 numbers when I multiply will give me -32, but add up to -4. Well, that's going to be a -8 and a +4. Okay, when I multiply them, -32. When I add them, -4. Let's put it right in factored form. I get x minus 8 and x plus 4. You're done. Okay, so again, if they were asking you to solve, right, keep setting it equal to 0 like this, and then you would take each one of your factors, set them both equal to 0, and solve. All right, so for this one here would be x minus 8 equal to 0, x plus 4 equal to 0, and then you just solve it. So I would get x equal to 8 on that first factor, and then on this one here, I would get x equal to -4, right? So if you can factor them, you can definitely solve them. Factoring them is definitely the more challenging part. Once you factor it, I mean, it's pretty simple to solve them, all right? Okay, let's go ahead and try one more example here. So here's our last example, and it looks challenging, but it's really not. We just have to follow our steps. First step, set it equal to 0. So that's what I need to do. So this -3x squared, I'm going to add it, okay? I'm going to add it here, and I'm also going to add it here, right? Balancing out that equation. That will cancel here. Here, this +2x, I'm going to subtract it. Do it on both sides. Okay, now we're ready to go. So that will cancel here. A -2x squared plus 3x squared, that will give you 1x squared, or just x squared, right? Okay, -5x, -2x, that gives you -7x. And then I'm going to have +6. Okay, +6, all equal to 0. Okay, from here, can you pull out a greatest common factor? And I cannot, right? So I go right into the AC method, a times c. That's going to give me 1 times 6. That will give me 6. So 2 numbers when I multiply, that will give me 6, but add up to -7. Let's just start with 6 and 1. When I multiply those, I do get 6. When I add them, I get +7, not -7. All right, well, what happens if I make them both negative? If I make them both negative, when I multiply them, I do get the +6, right? Because I'm multiplying 2 negatives, that will make a positive. And then when I add them, I get the -7. That checks out. So from here, I'm going to put it right in factored form. I get x minus 6 and then x minus 1. And that's done, right? So that's completely factored. So that is how you factor quadratics when a is equal to 1. Again, it is a little bit different when a is not equal to 1. You have to do something called factor by grouping, and there's a few more steps involved. And I am going to put out a video on that, so be on the lookout for that video. But that's pretty much it, right? So factoring is pretty straightforward. Just make sure you follow those steps, right? Set it equal to 0, see if you can pull out a greatest common factor, and then perform the AC method. So if you found the video helpful and you gained something from it, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.